Our project is particle-based multi-fluid and rigid body interaction. We implemented a particle-level set fluid simulation system that can handle both multiple fluids and rigid body interacting at once. Our group members include Wei-Chien, Xinji Ma, and Zihao Feng. Xinji is responsible for the fluid part. For the first part, the particle-based fluid solver, and Zihao Feng completes the rigid body interacting simulation. Wei-Chien is responsible for fluid mesh reconstruction. Here is our reference papers. And first, I'll talk about our multiple fluid solver. The core of our framework is based on the Fluid V 2.0 framework, which was developed by Roma. This framework takes a particle-based approach to solving the Navier-Stokes equation and the simulated fluids. This fluid solver uses Lagrangian viewpoint and stores values like mass, velocity, position in particles. Particles concentrate mass as a point and represent a discretized continuous field. Smoothing corners are used to describe description of attributes around particle. We have implemented our own fluid feature upon this base, and to enable multiple fluids interact with each other, we define two kinds of particles according to the paper Multi-Interacting Liquids by Frank Lassasso. We tweak fluid properties like viscosity, density, and mass to get interesting fluid interaction effects.
After we got the simulation result, which is a data array stored of the particle position of each frame, we could construct the surface mesh from this data. We use the margin cube method as our base algorithm. The main idea of margin cube method is to determine whether a vertex is inside or outside of our surface, and then we could find out the surface boundary, which is located between inside vertex and outside vertex. However, what we only have is the position of each particle, and the information is not enough for us to construct a surface. So we provide a virtual sphere for each particle, which is shown as the blue dashed circle in this figure. The blue dashed circle. Here we use 2D figure to explain a 3D method. However, the concept for 2D and 3D are identical. Every virtual circle encloses several neighbor vertices. We assign values for enclosed vertices according to their distance to the particle. The further distance is, the smaller value was assigned. After we find out of the surface boundary, then we could create a closed surface mesh like the red line, this red line. And in order to let our surface mesh looks more smooth, we use level set method to do further calculation. We take the surface mesh which was constructed at the last step and set a negative distance value to do level set method computation. Negative distance value represents the location inside the previous surface mesh. We could observe from this figure the green small rectangle represents the locations inside the surface mesh. When we find out these locations, we could use margin cube method to construct a new surface. From these three figures, we could see that the first step results, which only use margin cube method, and the third figure is the result after doing level set computation and the second time margin cube method.
Well, beside the multi-fluid simulation, we also implemented the rigid body interaction. The simulation is based on a 2006 thesis on rigid body simulation by Rahel Baber. It deals with trying to model real-world physical situations computationally by applying Newton's laws of motion of perfectly rigid bodies. The two main features, by applying Newton's the two main features of the simulation are collision detection and collision response. The base code is from Mr. Danny Chapman, and it is with the third-party library called Simple Direct Media Layer. What we did is like we modified some of the base code and we implemented OBJ file loading method. That is better for us to create more complex scenes like more quickly. So here comes the simulation results for the rigid body simulation. Okay, so after simulation of the rigid body itself, we implemented the fluid rigid body interaction. It is based on the paper Impulse-Based Rigid Body Interaction in SPH by Sakutai, Ohio, and others. This part is the high demanding part. It has high demand for simulation time and device. And the other challenges that we faced are mesh reconstruction, impulse-based boundary force, normal determination, and something else. So what we did, you can see like there are two simulation results. The first one is multi-fluids dropping on a rigid body. Okay, so you can see that the two fluids are simulated, but there are some problems with it. As you can see on the bunny's head, where the skin is so thin, the simulation is not that perfect. Okay, so the next one we did is rigid body crashing multi-fluids. All of the simulations are rendered with Cycles Renderer in Blender. And thank you so much for watching.